Ever wondered how scientists separate mixtures into their individual components with precision? The answer is chromatography. This ingenious technique has been a cornerstone in the world of science, particularly in the realms of pharmaceutical and chemical analysis. It's a method that allows us to break down complex mixtures into their individual components, making it possible to study them in detail. Chromatography, in essence, is a game of hide and seek at a molecular level. The mixture to be separated is introduced into a system, and each component interacts differently with the system, causing them to separate at different rates. This separation allows scientists to identify and quantify the individual components. Whether it's to ensure the purity of a drug, to identify unknown substances, or even to study complex biological samples, chromatography is the go-to technique. It's a powerful tool that's integral to our understanding of the world around us. Understanding chromatography sets us on the path to unraveling the mysteries of USP Chapter 621. USP Chapter 621 is an essential guide in the world of chromatography, but what does it entail? Unveiling the Veil, USP Chapter 621 is a pivotal element within the United States Pharmacopoeia, a comprehensive resource for all things related to pharmaceuticals. This chapter in particular is dedicated to the procedures and guidelines associated with chromatography, a crucial analytical technique used in various industries, most notably in pharmaceuticals. So, why is USP Chapter 621 so significant, you may ask? Well, it provides a structured approach to chromatography. It details the conditions and parameters for testing, ensuring that the results are reliable and consistent regardless of where or when the testing takes place. It's like a universal language for chromatographic procedures, understood and followed by professionals all over the globe. But USP Chapter 621 isn't just a rulebook. It's a living document that evolves with the field. As new advancements and discoveries are made in chromatography, USP Chapter 621 adapts, incorporating these changes to ensure that it remains up-to-date and relevant. It's not a static set of rules, but rather a dynamic guideline that reflects the ever-changing landscape of this field. Now let's talk about what's inside USP Chapter 621. It contains several sections, each one dedicated to a particular aspect of chromatography. These sections cover everything from system suitability and chromatographic conditions to chromatographic reagents. Whether you're a seasoned professional or a newbie in the field, USP Chapter 621 has something for everyone. To sum it up, USP Chapter 621 is more than just a chapter in a book. It's a guide, a tool, and a resource that ensures we all speak the same language when it comes to chromatography. It's a testament to the collaborative spirit of science and the pursuit of accuracy and consistency in our work. Now that we know what USP Chapter 621 is, it's time to delve deeper into its sections. The first section of USP Chapter 621 introduces us to system suitability. Now, what is system suitability, you ask? Let's dive into it. System suitability, in the realm of chromatography, is a series of tests to ensure that the system is apt and ready for the analysis. It's like a pre-flight check for a pilot, ensuring all systems are go before takeoff. This crucial step is carried out before any actual sample analysis. It's an integral part of the quality assurance process, assuring us that the chromatographic system is operating correctly. It also verifies that the method's performance is consistent with what was established during validation. System suitability tests could include parameters like resolution, tailing factor, theoretical plates, and many others. These are essentially the performance indicators of the chromatographic system. They're like the heart rate, blood pressure, and temperature readings in a medical checkup, fundamental indicators of health. But why is system suitability so important? Well, without it, we could run the risk of inaccurate or unreliable results. Imagine running a marathon without a proper warm-up or check of your gear. You could end up with a twisted ankle, or worse, a DNF. Similarly, without system suitability, our chromatographic analysis could run into serious issues, including inaccuracies and errors that could impact the final results. System suitability also acts as a bridge between method validation and sample analysis. It brings together the theoretical and practical aspects of chromatography. It ensures that the system is performing at an optimal level and is ready for the actual analysis. It's like a dress rehearsal before the actual performance, ensuring everything is in place and ready to go. Moreover, system suitability is not a one-time thing. It's a continuous process that needs to be carried out regularly to ensure consistent performance. Just like a car needs regular maintenance to run smoothly, Our chromatographic system needs regular system suitability tests to ensure it's performing optimally. System suitability, indeed a vital section, but hold on, there's more to USP Chapter 621. Scene script. Next in line we have chromatographic conditions. Let's delve into the heart of chromatography, the chromatographic conditions. This section of USP Chapter 621 is the conductor of the chromatographic symphony, orchestrating the interplay of factors that determine the success of your separation. Firstly, we have the mobile phase. This is the solvent that carries your sample through the column. Changing the composition of the mobile phase can significantly influence the separation. For example, altering the ratio of organic to aqueous solvent can change the elution order of analytes. A careful balance is needed here, as the mobile phase needs to be strong enough to elute the compounds yet gentle enough to preserve the column. Next, we have the column. The column is like a maze that the compounds in your sample have to navigate. The length, diameter, and particle size of the column, as well as the properties of the stationary phase, all contribute to the separation. A longer column provides more interaction opportunities between the sample and the stationary phase, leading to better separation. However, it also increases the time and the amount of solvent required for the run. Temperature is another key player. It not only affects the viscosity of the mobile phase and the diffusion of the analytes, but it can also impact the selectivity of the separation. In general, a higher temperature leads to faster elution but may also decrease resolution. Lastly, we have the flow rate. This is how fast your mobile phase travels through the column. A slower flow rate gives the analytes more time to interact with the stationary phase, improving separation. However, it also increases the time for the run. In sum, adjusting the mobile phase, column, temperature, and flow rate can help you achieve the optimal separation of your sample. It's a delicate balancing act, requiring a deep understanding of the principles of chromatography. Adjusting these conditions can make a world of difference, but the chapter isn't over yet. The final section of USP Chapter 621 brings us to chromatographic reagents. This part of the chapter is all about the role and importance of different reagents in the chromatographic process. Now, let's dive in. Chromatographic reagents are the chemicals used in the process of chromatography. They play several important roles, including acting as the mobile phase or the stationary phase, aiding in the separation of compounds and enhancing the detection and quantification of these compounds. For instance, a reagent like acetonitrile or methanol can act as the mobile phase in a liquid chromatography experiment, helping to carry the sample through the column. But here's the thing, not just any reagent will do. The choice of reagent can significantly impact the results of the chromatography. Each reagent has its own unique properties such as polarity, acidity, or basicity, which can influence how it interacts with the compounds in the sample. This, in turn, can affect the separation and detection of these compounds. For instance, a highly polar reagent might cause polar compounds in the sample to elute more slowly from the column, while a less polar reagent might cause these compounds to elute more quickly. This means that the choice of reagent can directly impact the resolution of the chromatography, or how well we can distinguish between different compounds in the sample. Moreover, the reagent can also affect the sensitivity of the detection. Some reagents can enhance the signal of certain compounds, making them easier to detect and quantify. On the other hand, some reagents might interfere with the detection of certain compounds, making them harder to quantify. So, you see, the choice of reagent is not a trivial matter. It requires careful consideration of the properties of the reagents and the compounds in the sample, as well as the goals of the chromatography experiment. With the right reagents, we can achieve the most accurate results. That concludes the sections of USP Chapter 621. We've journeyed through the depths of USP Chapter 621. Now let's summarize what we've learned. We've unpacked the fundamentals of chromatography, a vital separation technique in the pharmaceutical world. We've dived into the complexities of USP Chapter 621, a cornerstone document that provides essential guidelines for chromatography practices. We've understood the importance of system suitability, which ensures the system's readiness for analysis, and the significance of meticulous chromatographic conditions, which can make or break a chromatographic separation. Lastly, we've discovered the role of chromatographic reagents, the silent heroes that facilitate the separation process. Each section of USP Chapter 621 is an integral cog in the larger machinery of chromatography, each playing its own unique and vital role. With this knowledge, we are better equipped to understand and navigate the world of chromatography. Here's to more scientific explorations.